Okay, good morning, everyone, and welcome to Thursday Zoom presentation. I'd like to welcome Nils Backeberg today. Nils is a very active and supportive member of our OGG group, and just to say that in where we now, November and October, he organized us a tremendous field trip over a long weekend up into the Cedarberg, Bali Sakhat, and if you haven't been there, I'd strongly recommend it, and we're certainly going to do it again next year with Nils. So all the locals, we look forward to having you along. Just by way of background, Nils graduated at UCT in 2009 with his honors degree, 4-year degree, and then also did an MSc there and finished that in 2012. And then he went on to do a PhD at McGill University in Canada on structural economic geology of the Archean gold in Canada. So he's got a lot of good economic background, so to speak. Subsequently, he's worked in industry, and his most recent position was with Roscoe in their market research group, where he has worked on a number of the commodities, steel and alloys being one of them, and others. He's now sort of taken a sabbatical and looking to, I believe, start some new ventures in 2022. Anyway, Nils, thanks for making yourself available, and we look forward to your presentation. Over to you.
Thanks, John. Thanks for the introduction. It's good to be speaking in a private capacity. Let's see, enjoying the rest of the year as an unemployment and see how the rest goes. But thank you everyone for joining today, and thanks for the opportunity for me to speak to you again here on the group. What I'd like to talk about today is a bit more of sort of the driving factors, sort of external factors to exploration and interest in geology, mainly from non-geologists, sort of from raw material requirements, and think about not only the impacts of technologies and the main narratives that we're seeing, like energy transition and those impacts on raw materials, but also something that's called critical raw materials or criticality. What is criticality and the perspectives, and sort of lead that into a discussion if people want to chat about that at the end about, as South Africa, what is our role in sort of raw material supply chains from a more opportunity perspective. Really some questions that I think the DMRE should be asking itself, how do we capitalize on the geological heritage that's in this country? So a lot of this talk will be more about the conceptual, about market drivers, key aspects, and I'm going to have one or two tangents in there, and then going into what are the current narratives. And when I was putting the slide together, I conveniently borrowed this opening slide deck here from a White and Case webinar that they put together on the energy transition. And I thought it quite in a complex way, shows the complexity of energy transition and what are the current narratives that are taking place in there at the moment. Right, and the first thing that we can see here, it's not a straightforward narrative that we have. We've got the oil industry, its impacts, you can see here. We've seen negative crude oil prices over the COVID story. So people are saying, are there different narratives? And when you're talking about energy, we always come back to the renewables, so wind turbines, solar. What are the driving factors behind that? What is pushing that change? And the industrialization, how is the industrialized world being impacted by this, right? Topics that we're all familiar with these days, electric vehicles. There are technologies coming to the forefront that are driving a sort of net zero contribution. I'm just quickly going to start my watch here so I can see what time I'm doing. And then along the way, if you skip to the top of the graph here, you've got enabling technologies. These are technologies or energy applications that help us towards the road of sustainability, but don't offer the actual solution. And gas is one of those. But then there's also the political and the financial aspects of it. People want to invest the appropriate risk and reward, and what is the financial impact of going to renewable energies. But we are seeing an energy transition. We're seeing the reduction of coal, the growth in renewables. There's still lots of issues with renewables. And then further forward in the future, we're looking at hydrogen economy. How's that taking place? Still requires a huge infrastructure. But all in all this is doing, as part of this narrative of building a sustainable planet, is it requires a shift in the raw material requirements that go alongside with that. So we're going to address some of these key points, look at what it is we have and where are we going. So where is the current interest that we're looking for? So why do we mine? Fundamentally, it's because we need the raw materials in the ground. And here you've got a figure from the World Resource Institute showing the consumption of material in the USA between 1900s and 1990. And you can see the growth in sort of firstly primary metals, then red, showing you the increase in primary metal consumption, quite stagnant over the second half of the 20th century, and starting to decline here, where we're seeing replacement by this dark blue, which is secondary metals. So this is sort of the recycling loop. If you look at this on a global scale, you'll see this red bar really continue to increase. And a lot of that has to do with the industrialization of China. The steel industry really, that's really the start of the 21st century. Between 2000 and 2020, China's really invested heavily in the steel industry. So while this US picture paints sort of more focus on industrial mineral growth, when we look at global, the primary metals market is something that has grown quite significantly. Taking another step back, what is driving this? Am I still on here? Sorry, my screen's just gone blank. John, can you quickly jump on and let me know if this is still recording?
You're okay.
All good.
You're okay.
All good.
Okay, thank you. Sorry about that. Right, and so that the population growth is one of the key driving factors that underpins demand. So this is the latest publication by Our World in Data showing you where population trends are from 2019 and the projection. And we're seeing populations effectively doubling every 100 years or so. And, we've exceeded that over the last 100 years. But that's really what is driving the growth in requirements of raw materials. So commodities that we all know when we go into the geology, economic geology classrooms, and we learn about the different commodities that are being mined out of the ground. We're talking about sort of the gold, the coppers, the iron, aluminium, and also the oil industry. These are some of the sort of major industries that we see that have underpinned the growth of industrialization. And those trends are starting to change to some degree, but still these are very important minerals and metals and materials to sort of go hand in hand with that growth. And here just showing you some of those trends. So for iron ore, aluminium, steel, and copper here on the bottom left, you can really see there over the last, well, this is 2 decades, a little bit more, 2.5 decades, you can really see these industries more than double or threefold in scale over those last 30 years. The oil industry itself also doubling and increasing, that's the requirement for transport and energy to meet the demand of the growing population. And so these are really some of the key trends that we're seeing. And a lot of them, steel and oil, come with quite a large carbon footprint in the production process and its applications. And so this is starting to address some of the key issues that we're seeing today. Then obviously, we've also got the precious metals, which have really been important, not only from investments, but also in some certain applications, the PGMs, as part of the automotive industry and others. But you can see here, just in the top right, looking at your gold production over the years, we're based out of South Africa here. You can really see the importance of South Africa in terms of that growth, and that really underpinned a lot of that economic development here. But over the last 50 years, you can see how that's been turned on its head. In part, that's been related to heap leaching and new process technology to being able to process lower grade ores. Right? Still part of the supply chain, but we really see the growth in gold supply outside of the country. And a key aspect and point that sits behind that is technology development. It's not only the grade of the ore that we're processing, but also the technologies that we use to process ores in place, right? And so it's technological development that don't only show what type of materials we need, but also the types of materials that we can process. And as we're going into more niche markets, those become slightly more complicated. The mineralogy behind certain elements in the ground is very complex compared to, for example, gold, which sits as free gold mostly in between the mineralogy in quartz veins, for example. And we can see all of that come together. Now, interestingly, when we're looking at, there's one quick tangent here going into a bit of geology and mining in this. The value of the metals, is driven by demand for it, and the rarity of that metal in the ground effectively determines, in essence, its price together with those factors. And we can really see here that, this graph here at the bottom left is showing you just a slight correlation between sort of the highest grade ores that we find of a certain metal and its value that we see. And this was taken, I think I put this together in 2018. So, prices will move slightly depending on supply and demand dynamics. But really, we can see that, it's most valuable to dig deep to go for gold and platinum. And that's where we're seeing in this graph, which is from Wikipedia, showing you the deepest mines in the world. Right, whereas chromium, one South Africa is quite rich in, we see mostly open cast mines starting to go underground, but it becomes an economical sort of hurdle to get that chromium out the ground. But we do see that sort of byproduct plants or mines where you can get multiple values out the ground can start to get those opportunities together. And again, sticking with chromium is quite an important narrative for South Africa, because the platinum industry, specifically those mining the UG2 chromatite, they can get their byproduct chromite off the ground. And all of a sudden, that's putting pressure on our primary mines, because we're actually now getting chrome out of the ground from 2-3 kilometers underground, or 2 kilometers underground, rather than the primary mines having to focus on surface material. So the value of material allows us to explore in certain areas for different metals. And so this is really where the demand market leaps in and pushes and allows for the academic world to address certain geological processes. And we've all seen this image looking at the tectonics of ore deposits. It's effectively our guide for exploration, right? And so this is really just putting together the plate tectonic situation on planet Earth and where we're finding what types of deposits, i.e., where do we see materials moving around, redepositing, re-enriching, or enriching and depleting, etc. And this is really focused around, historically, when we talk about this, where's gold, where's copper, where's oil, etc. We look at the tectonics and the environments that we see. Where do we find these metals? Right, and as part of that, we start to map out structures. We understand the structural controls of these elements, and people have done a lot of work on gold. And I spent a lot of time in Canada looking at Archean gold deposits and comparing that to the rest of the world to try and understand, was diaprism the main tectonic process, or did plate tectonics also operate, etc. And that's a whole discussion in itself. But what we get to do here is we then start to identify different earth processes. This is a colleague of mine at McGill who put together sort of the migration of fluids through the seismogenic zone. And effectively, this is how gold moves through the crust and becomes enriched, and through a sequence of earthquakes comes to the surface. All right. And so we've been analyzing and studying this within the scale of the crust based on quite a lot of funding from industry. And we're seeing a lot of that now change with the change in commodities. We're going to see abilities to delve deeper, not just stratigraphically, but also chemically and process-wise into all these different minerals and metals that come to the markets. So what do those look like? And I would just like to come back to this graph and come back to the current narratives, right? So the nostalgic part of earth sciences is done now. We've looked at what has really driven the economic geology world, but now what is doing the current world, and what are the key narratives? So the first one, climate change, right? A narrative that we're seeing in the news, we're seeing across politics, believers, non-believers, atheists towards climate change, I imagine, a lot of geologists saying, it's part of the natural cycle, but effectively, what is the anthropogenic impact on the climate systems that we're seeing? That is really the fundamental that we're trying to understand, and how can we build that, or how can we live with that? So the key question that comes out of this is, how do we actually build a sustainable planet? Now, these narratives all fit in with the global climate change issue. If the planet was happy with what we're doing, the amount of CO2 we're putting out into the atmosphere, and if that wasn't impacting our health, then this wouldn't really be as much of a narrative to talk about. So here's two pictures of Beijing. We can have the discussion of which is the before and which is the after picture, and unfortunately, it's not the way around you'd want it to be, but it shows that China, they have the ability to switch on and switch off heavy industries for certain events, and they can create blue sky policies in quite short term. Now, I say that quite loosely, but it's actually very important on the global scale, because the impacts of policy has been a very, very key point in this energy transition. And COVID-19, 2020, and now period has really accelerated sort of its implementation on a global scale. So the figure I'm showing here on the left, the CO2 emission standards, is for automotive vehicles. This is something Roskill put together back in 2017, and with a projection of where that are, so this would have evolved since then. But you can see that the standards are really becoming more stringent. This has been really key for platinum group elements being put into emission catalysts. So needing higher loading, rare earths are also put in there, but not the main metal being used. And so despite, the changes that we're seeing in electrification, I'll come back to that again, of automotive vehicles, the platinum industry is still going to see quite strong demand as these kind of technologies become more and more stringent and require higher loadings of metals. So policies have direct impact on the amount or the technologies of raw materials that we need in order to comply with these standards. Right? And so the key question here is how is this being addressed? So we need cleaner technologies. These come at a higher operating cost, i.e. there's more cost related to it. And the last one is less demand. Rather than the recycle approach, is a reduce and reuse. What are we as a society consuming? These are big narratives that are looking at how they are impacting raw material markets and those key drivers. Together with that, we've got the renewable energy environment and the growth of that. So here's some data put together by EIA. I think this was published also in 2015. So this is from a while ago. So there'll be newer versions of this, but effectively those trends that they've been forecasting are still taking place, i.e. petroleum is still the main form of energy and its liquids used globally. Coal has reached a plateau. Coal itself has a very interesting narrative at the moment regarding to energy security for the Northern Hemisphere winter that's coming their way, and there's shortage of thermal coal, there's shortage of gas in Russia and across China. So there's some serious issues regarding the thermal industry in the Northern Hemisphere this year. Natural gas, I mentioned the sort of transition energies. So natural gas is going really well, but really the forecast is that renewables has a strong growth in here. So here we're looking at wind, hydro, solar, geothermal, you name it, and the whole point is that they need to work in unison in order to have any meaningful impact. Nuclear, I think, is probably worth discussions on its own. If you look at sustainability studies, all of them point out that nuclear is one that is quite useful in order to meet a net carbon zero environment, etc. However, it does come with certain barriers from acceptance from both policies, also every human being, in terms of their appreciation or feeling safety around nuclear energy. So it has some issues related to it. However, it does play a key role, and it can play a key role in building sustainable energy supply. Right, so what I'm going to turn now is start focusing in on the new technologies and the drive towards raw materials, but just give you a bit of background of what underpins that. So the two figures here on the left are showing you development of new technologies, building up to bring it into market, and and then it's accelerating in an acceptance, i.e. your product is successfully launched, gets taken up by a consumer market and reaches some level either of optimization and then plateaus. Okay, you've captured the market, or alternatively, rather than the bottom graph here, so saying it's transition, i.e. it's implementation, sort of ramping up and then reaching a level, depending on how much substitution it enacts on other applications in the market. Or alternatively, it drops off completely, which means sort of a failed product and back to square one. So while we've got this acceleration and sort of market penetration that we're seeing, we also have the cost of material. So the cost starts to increase. First in the R&D stage, you don't pay yourself any money. Then you have to start scaling. You need larger equipment, and you really reach a sort of peak of cost of production. And once this market takes off, i.e. brought a successful product to the market, now you no longer need to increase the scale of the infrastructure around it. You just increase the scale of product, and then all of a sudden your optimization starts in terms of cost. You optimize materials, you find long-term agreements, etc., and you start to reduce that. And this is quite common. We see this in a lot of applications: solar, wind turbines, electric vehicles. They all follow these trends. And solar, a few years ago, really ramped down this trend very, very quickly. That was the PV panels that were coming out. And before that, there were two different technologies. You had the mirror heating of the water pipe for using solar energy, or the PV glass. And PV glass was a lot more expensive to start, but then very, very rapidly overtook the market. And that is now the used application. Right, and what was interesting for this, in many of the renewables or electric vehicle markets, you reach this market takeoff, but you compare it to its competitive applications or its competitive products, it is not cheaper. It is more expensive. And so that means you have to convince the consumer market to actually spend more money to do this, to buy this product. And that's often very difficult to do. And how that's been achieved on a global scale for the renewables and also for electric vehicles has come out of subsidies, i.e. this is meaning that government has come in and said, okay, we will subsidize these industries and support its offtake, because there's a longer term benefit that they see. And once these industries grows, the cost starts to decrease. And during this optimization period, they potentially become competitive on a cost basis to its substitution market. For example, electric vehicles versus a normal internal combustion engine vehicle. Right? So there's that substitution issue that needs to be engaged. But the driver now behind many of these higher cost technologies is the climate change narrative, sustainability, net carbon zero. So the people are throwing money into the industry to actually help them kick off. And so again, that's quite a different status at the moment. And electric vehicles is a very key one, and we're still at this early stage of the peak. So market is now taking off. This is, if we look at over 2020 during COVID-19, the adaptation of electric vehicles continued to grow, whereas internal combustion engines declined for COVID-19 reasons. But we're seeing several revolutions come together from a consumer basis. You've got the electrification, autonomous vehicles, and shared driving. So we're actually changing consumer behaviors. We want to buy electric vehicles. Okay, in South Africa, it's difficult to say that. The infrastructure is not there to support it. Nor is electric vehicles potentially the ideal solution in South Africa with the distances that we drive. But again, that's another conversation. But what's actually happening is that these changes in consumer behavior are meaning that the automotive industry has already started to actually decline in total annual sales per year. And this is something, when you look at a forecast from 2017, it continued to increase over the next decade. And now we're already seeing us having potentially reached a peak new annual car sales figure last year, or no, not last year, it was even this year, I think. Nevertheless, we're seeing a plateauing of car sales declining. At the same time, electric vehicles are ramping up, and here's sort of the forecast from Bloomberg, still very low in terms of its actual percentage in the industry. But by 2040, here Bloomberg saying 35% of all new vehicle sales will be electric. This ranges on a regional basis, depending on who's looking at it. But the point is, electric vehicles are ramping up, and we're talking here of 100 million vehicle sales a year. So you can do the maths then, you're getting quite, we're seeing the shift come out. What has allowed this to take place, and that is really batteries. And batteries is a key technology, not only for electric vehicles, but also for renewable energy. Right? We're producing all this energy, and we need to store it, otherwise we're losing it. So our efficiency of using energy is historically very poor. And now we're producing high cost energy. So we need to make sure that our efficiency of using that energy is better, so that our payback for the investment that we do actually pays off. Otherwise, this doesn't make sense. Right, and again, showing you this graph now for where different sort of battery technologies are at the moment. Solid state batteries also starting to take off, but lithium ion really along the way of sort of market acceptance and in line with being adopted to all these electric vehicles. Right? And it's interesting, when you look at the automotive industry, they sort of operate at 7-year timescales. This is now a large industry. Lithium-ion batteries is not a new thing. If you look at the demand growth for them, cell phones, they saw a huge increase in demand over the 2010 or 2000s and 2010s, but then sort of plateaued because they're relatively small batteries. Now, the automotive industry is a big beast, and it moves fast, and it has adopted this technology. So the growth in demand is growing, and the growth in demand is coming, and it's being driven by the fact that you've got one of these major sort of macroeconomic sectors driving the demand. Right? And so we're seeing this, and it's having and have a huge impact on raw materials. Right? So here, looking at technologies and the different raw materials, cell phones are a great example. The amount of materials that go into these phones is spectacular. And Apple talked to research houses that cover all these markets to try and understand what is the supply security of this, where can I get this, and are there substitutes, etc. They're doing a lot of work into this. Aerospace industry, aluminium, advanced composites, titanium is a massive industry for the super alloys in the aerospace industry. Then here I've got an electric vehicle there, or the Toyota Prius, but from a rare earths perspective, they were still using nickel metal hydride batteries, which are a lot cheaper than lithium ion, but hence they were only hybrid vehicles because they couldn't get the same range. And then specifically batteries, the amount of material that goes in here is staggering. And here you've got a sample cathode material, like nickel, cobalt, and lithium. Those are sort of your key minerals that are now being started to focus on. So the commodities that we need to get used to looking forward are changing somewhat. It doesn't mean we've gotten rid of gold, silver, and copper. They are still part of the infrastructure. They're still part of the technology chain, especially the precious metals. Copper, on the other hand, is still going to be in there as part of the cabling infrastructure. So I see they've left it out over here. So I would say that needs to be on here. I don't know what the gradings are in here. But you can really see some of these more niche metals that we haven't spent that much time looking at. Niobium is one predominantly used in steel, but it's a very, very small market in comparison. And then rare earths really are important. And so rare earths, again, is their own conversation in there because you've got 15 different metals. But this whole energy transition is really just focusing on 2, namely neodymium and praseodymium, plus minus dysprosium and terbium, because they're used in magnets. And now magnets are used in motors and they're part of this efficient energy consumption, right? We've now produced expensive electricity through renewables. Now we need to store it so that we can use it when we need it. And then when we need it, we want to convert it into as much energy as possible. And this is where magnets are coming in. And these neodymium rare earth magnets over here are the technology of choice at the moment for mobility, right? So specifically mobility and low maintenance structures. So offshore wind turbines, which generate the electricity, also use these magnets with the same principle. And so we're seeing quite a lot of materials in there. So what I'd like to jump over quickly just for the end is to focus on critical and strategic minerals. What is that? And how does this new era of materials go into effectively a political conversation? So what defines a critical raw materials, right? They're materials which are economically and strategically important, but have a high risk associated to their supply, right? They're used in key sectors. So basically, if there's an important sector for a country and it requires a certain metal that has a low substitution risk, but you do not have that supply domestically available. It becomes a critical material, right? So strategic importance, have a high supply risk, and there is a lack of substitutes. I.e., if that supply breaks off, there's not many alternatives to go there. And looking at the recent developments of lithium ion and rare earth magnets really fits in with this narrative, right? And so here's a PhD or a summary from a PhD study by Jack Bedder put together, looking at the European Commission, where the different materials are being mined, and where there is a high centralized supply. And you can see the list of materials mined in China. So this is primary material out of the ground, and we mentioned antimony earlier, rare earths, tungsten, magnesium is a big one that's causing many narratives from a China perspective. South Africa is there with the PGMs. We could add chromium in here if we wanted to. Obviously focused more on non larger scale volumes. And then niobium, one I've already mentioned, Brazil, 90% of the market, and then cobalt for the DRC. So the criticality really is dependent on what you're looking at. So cobalt is only critical to a country that actually utilizes it in its application, right? And so on top of that, we've got the political influence. Trump, here's an example of geopolitics that took place in 2018, 2019 with tariffs, where the US and China were going head to head saying, I will put tariffs on your trade. And then there were these counter tariffs. But ultimately, the key importance behind it was the tariffed items they were put in. A lot of the critical materials they were talking about weren't implicated on that. I mean, it doesn't matter that Trump says we will put tariffs on imports of rare earths from China, because they actually all get mined in China and processed in China. And more so, what was quite interesting, here's an old map I put together of rare earths, that right in the middle of this time, this is a map of rare earth deposits and mines. It's also from 2019, I think. Lots of deposits of rare earths, not a shortage of supply, but most of the mining is taking place in China, but also most of the mined material outside of China is making it into the country. Specifically, as I was saying, during that political back and forth, the Mountain Pass, which used to operate previously, came back online, but under a Chinese consortium ownership, and actually all gets exported into China now. And that was in 2017 or 2018 when this came back online. And since then, they're still talking about building an independent processing plant in the USA, but it's really a highly political issue of doing so. But the problem is, once you've separated and produced different rare earths in the US, the next step in the supply chain is also in China. So looking at criticality of it, when you're saying there's a certain critical raw material from my perspective. So this is what the European Commission put together. This was their 2010 version, right? You can see there's a supply risk. Rare earths is right there. It's all being produced in China. Its economic importance relative to some of these other applications are low. Niobium, all in Brazil. It's a key part of the steel industry. HSLA, which is construction steels. Chromium, high economic importance, or the highest economic importance, yet they've put it at quite a low supply risk. And that's because there are a couple of mines in Europe, so that includes mainly Kazakhstan, Turkey, and Kazakhstan's a bit of a stretch of implication if it's part of it or not, but it is part of the supply chain, and then obviously Finland. But actually a lot of the supply was still coming out of South Africa, but they had some domestic availability, so the risk was mitigated. Right? If you draw this for China, chromium supply risk will be very high because they import 100% of their chromium requirements. Now, if you look at sort of how these markets are changing because of the consumer markets, we are seeing things moving. So PGMs are going to decrease, at least in the short term, in terms of the economic importance, as internal combustion engine vehicles reduce in volume. Rare earths will increase cobalt, lithium. Manganese is already up here. The supply risk might increase for manganese, which is also important battery material. So what I'd like to finish off with is saying, so understanding criticality of raw materials, it's not just about what's in the ground, but it's actually part of the entire supply chain. And so you've got chromium, some examples of here. Chromium manganese is one that I like to work on because it's also very central to South Africa. There's the ore and concentrate part of the supply chain, the ferroalloys, and the stainless steel side of things. Right? And so we can look at, where are the opportunities in criticality? So when we add ore and concentrate, South Africa, for both of these materials, is the major producer. China only produces relatively small volumes. However, when you look at the ferroalloys, it's already shifted to China. If we go a step further into stainless steel, China produces over 50% of the world's steel and stainless steel. Right? So the criticality there shifts. South Africa has not got a critical aspect for chromium, but it has a criticality for stainless steel to meet its demand. Right? So one has to remember the entire supply chain is in there. So this is where one then looks at where are opportunities to invest in further processing power or capacity. And the ferroalloy industry is a very useful example in South Africa where that's failed. South Africa used to be the largest producer of ferroalloys, chromium and manganese, but it's completely, manganese is effectively closed. There's only a few plants left. And chromium is holding on by a thread, and they're looking at export taxes, etc. Now, when you look at the battery materials here, lithium, nickel, cobalt, manganese, China is really sourcing this. And what this narrative is showing is China is very hungry for raw materials. So there is a lot of opportunity for just going down the mine route because there is demand, there's growing markets, and China is willing to buy all of that material. So that is really, and what USA and Europe are trying to do is they're trying to build their entire supply chain in here. And that is quite difficult because you can't just build the cobalt and the battery plant. Now, all of a sudden, you need to also build the electric vehicle chassis, which at the moment are also being built in China. So it's quite a heavy investment to capture some of these markets. When people say China's been playing the long game, this is really the result of that long game. And the same can be said for rare earths as well. Except rare earths, again, has further steps along the supply chain in terms of opportunity. But China really has stabilized itself in there. But there is growing opportunity in raw material supply because China's closed many of its mines for environmental policy. Again, there's an overriding narrative of sustainability, pollution, etc., that is also being implemented in China. So it plays a key role. So, just to finish this off, and I'll leave you with this slide open and you can have a conversation around this, is, what is South Africa's role in criticality? Right, so there's changing markets, there's raw material availability. South Africa's economy has really been built out of more of the historical sense of raw material supply. Does the country, do we as a nation need to look outside our borders and do the SADC approach of, utilizing lithium in Zimbabwe, copper, cobalt from the DRC, and, building a Southern African supply chain? And so, as I mentioned in this last slide, it's not just about the ore supply chain criticality. So the criticality perspective of Africa is more about how does it act as a raw material supply chain to the developed countries that are looking to feed in that and capture that market. Right, we can jump back to those as well, but that's it from me. How are we doing for time there? Thank you.
Thanks, Nils. Lots to think about, particularly those last two slides, and the second last slide, that overbearing red map, is quite notable. And I would imagine if you're a politician in the West, you should be looking at it carefully.
Yeah, I mean, and this is the whole point. Is the whole narrative when you look at the US and the European conversations. Are about how do they build a supply chain that excludes China, right? How can they be self-sufficient outside of China? And one can understand the argument because there's always been that back and forth between do we want to be reliant on China now, but China is really leading the way in technology developments in many ways, and I think Africa is in a unique position to benefit. And get involved in the evolution of these supply chains with China, because they are requiring raw materials to be part of that. So there is an opportunity here to do that. At the same time, the opportunity is there with the US and Europe, who are building these supply chains, want to make sure that it's sustainable. Cobalt is only mined in so many places, and you can build sustainable and ethical mines in the DRC, but it's the consumer base that is really driving these narratives, and that's one of the key changes that we're seeing.
Yeah, Agreed. All right, question time, ladies and gents. Maybe you, I mean, I think we've all seen that map. Now, maybe you want to unshare, and then people can open their videos and get into the discussion. Right. Questions, comments? Who's going?
John.
Hi, Richard.
Hi, how are you doing?
Good.
Thank you for that very interesting talk. The mix of metals and minerals you spoke about is very interesting. And obviously South Africa has major resources in many of these, particularly from the Belt complex. One of the metals that you didn't really mention, I don't think, you might have, was vanadium. And vanadium is now very important in storage batteries, flow-through batteries, redox batteries. What is your take on that, and why did it not figure in your critical minerals?
Yeah, no, fair point. Vanadium is one I should have mentioned, well, I was going to mention on that last slide of the map. You know, when we're looking at the raw materials in South Africa, vanadium is right at the top of the list. South Africa is a key producer of materials. You've got, you've got Bushveld, I forget the name, Bushveld Minerals doing their vanadium processing. And it is energy storage systems are a key narrative. Now, when you're looking at that curve of applications coming to market, energy storage systems right on the verge. It is proven to be very useful on a large-scale utility. So we're not talking about mobility here. This is energy storage on a static level. So where it really plays a key role is in renewable energy storage. I think that has a key role to play there. Now, a couple of years ago in 2018, Rongga in China built a gigawatt battery plant, but they never finished it because the vanadium prices were so volatile. So the economics of those went out the window very quickly. And so you had a whole surge in forecast growth for vanadium around energy storage, but that fell flat very quickly. Right. So it's definitely one of the narratives. It's one that needs a bit more care in terms of price stability. Right. So vanadium is largely used also in construction rebar steels, high strength low alloy steels. And when prices spiked like that, there was a substitution to niobium, which is used more or less in similar applications. There's some limitations of substitution. But the point with vanadium is that it's an intricate one in order for it to take off. That growth market is not yet set in stone. We've seen lithium-ion battery utility scale plants being built up. There was the one in Australia that Elon Musk said that, you know, if it wasn't done by week X, he'd give it for free. And that was to power a hospital, right? So that is the competition that vanadium is facing. Lithium ion is now a well-established technology. It's being applied not only in mobility, but in utility scale applications. So it's become a more common term in technology compared to redox flow batteries. Not saying that they won't work, but they've still got some hurdles ahead to meet that market. But absolutely right. If that market takes off, it is quite key. The supply chain for vanadium is also approaching some diversification because there's secondary supply from oil spent catalysts, which can be potentially quite large, and that will impact supply.
Yeah, thank you much for that. I think it covers the topic pretty well. It's still in the developmental stage in a way. And my impression is that vanadium caters for larger amounts of storage and higher quantities as opposed to lithium ion, but I might be wrong there.
Yeah, look, it's a more stable chemistry. So you can scale it up more safely. And it allows for the high density applications, but it's still, you know, you're still talking quite a large physical footprint for a battery. So the energy density, when you're looking at lithium ion batteries, it's about the energy density for mobility, i.e. lightweight, small, and high bang for your buck. Whereas vanadium, it's stable, and the maintenance is low. So for large scale applications, you still need a bigger footprint. So it will depend on the application.
Yeah,
okay, what Rich is also not telling us is he has a vested interest in Bushveld Minerals. And Richard, we have either Anthony or Fortune to give us a presentation on what you're talking about next year. So will you sort of wind them up and have a chat to them?
Absolutely. I mean, we've put a lot of effort into these, into as you know, from the steel point of view, and as I understand it, in China, their vanadium deposits are dwindling and the grade is pretty low, whereas ours are not. We've got 50% of the world's vanadium, and the grades are not bad at all. So one needs to look at this, and so, and also in China, there was a problem with their with steel, rebar used in construction, and many of the buildings were failing because there was not enough vanadium in steel to for the building of these high-rise buildings. So that amount of vanadium, there is now a law, as I understand it, where they need a certain percentage of vanadium in all their reinforced steel. So there are possibilities for this kind of thing.
Yeah, so the regulation isn't about specifically vanadium, but it is about the specifications of the steel product. And so they can get around that through different microalloying elements, such as niobium, and that's exactly what happened. But you're right, so the regulations that came into place in 2018 effectively imply the need for higher microalloying, which was vanadium is the main application, or the main alloy being used, but manganese as well, and then niobium. So yeah, it's not specifically saying you need to use vanadium, but it does imply the need for more material consumption.
So it's quite interesting that there is a comparative thing here going on between various elements, and that's quite interesting. And the outcome will depend on the results of research and further work, I guess. Absolutely. And the interesting equation here.
Yeah.
Okay, thanks, Nils, for that.
Thanks, Richard. More questions? Yeah. And I mean, while we wait for other questions, Richard and Nils, I mean, it takes us back to, you know, this country of ours. I mean, you mentioned the Bushveld, and you of all people, Richard, would know that, you know, we have this absolute jewel box here, and we have so many of these other things like rare earths. But we you know, we no longer have a mineral economics department of any substance in our DMRE or government. And you really get the sense, you know, that we not, well, we also have this, you know, really destructive legislation. I mean, you would have seen in the press in the last few days that the once empowered, always empowered issue is, you know, probably going to be now amended through legislation, having lost the court case with the Mining Council. And you just get the feeling that, you know, where we could be building, you know, a lot more companies like your Bushveld Minerals, which I guess is sort of a junior mid-tier company, you know, there are just so many roadblocks for small and medium-sized miners. And, you know, maybe that's, we did discuss it last year, but it's something we need to relook at again, because I don't think we're doing a great job of optimizing our mineral resources.
Yeah, thanks for those comments, John. They're very applicable. Yeah.
Yeah. Okay. Questions? Lou Ashwell.
Hi, it's actually Sue Webb here sitting with Lou.
Hi, Sue.
How are you doing? Great talk. Thank you. I wanted to ask also about fuel cells. I thought there was kind of, you know, playing out against China against the US in terms of fuel cells versus EV. And you know, is there any comment on the different resources needed there, but also about socially responsible investing and how that's affecting exploration? And, at the very bottom level of, people are divesting from oil and gas. We're seeing protests offshore right now about the Shell seismic surveys. And, is socially responsible investing going to, damage the supply chain? How do we keep it ethical and efficient? I mean, right now the supply chains are anything but efficient. So anyways, any more comments on those ideas?
Yeah, thanks for that. Those are some big topics. I mean, the first one, starting with the hydrogen economy and fuel cells. When you look at its application on a car, so you and me driving a car around, the infrastructure is not there to do that, not efficiently, and so that's the first hurdle. In terms of energy sustainability, it seems to be the right answer. So when you look at how do we produce energy, how do we use it, that's it. The efficiency is also quite low in comparison to other energy. So it's not, the technology has got scope to improve. And if they can improve the efficiency part of it, I think we will start seeing faster movements on it. Having said that, that doesn't mean it's not moving. We are seeing quite a lot of direction in there. And one great example is when you look at Anglo American here in South Africa at their platinum mines, they're now ordering a fleet of heavy-duty trucks, mine trucks, and they're built on hydrogen fuel cells, right? So again, when you're looking at that curve of technologies, they're effectively building their own demand base. Now they can, once they've got their own fleet, they can potentially start selling it, and all of a sudden you're starting to build a demand base for yourself. So I personally think that's quite clever. And what's unique in that aspect is that your driving pattern is predetermined, so your infrastructure becomes more simple. So if you take that a step further, the other place where we are seeing hydrogen fuel cells being implemented are bus routes, trucking, and those are the ones where we are seeing an economical opportunity to go that route more faster than lithium ion, because for a truck and a bus, all of a sudden now you need a huge battery. Not to mention the safety aspect of the chemistry, so you need to build your battery to the highest standard, but also the weight aspect. So again, your fuel efficiency plummets down, and their hydrogen fuel cell technology for trucking is one where we're looking at how much material they can transport from one side of the US to the other, which is where the study was done. Hydrogen fuel cell offers a great example, and it actually becomes more economical than diesel because also the weight of the diesel or gasoline, so there's a comment on that. The infrastructure is the biggest issue for that. And that will, again, once we see small projects here and they start, those infrastructures will develop. When you look at most analysts that are looking at the automotive industry, no one's really employing hydrogen fuel cell capacity before 2050, at least at a meaningful level for the automotive industry. That's generally because they forecast end at 2050, and that way they don't have to make a call. But Toyota, as an example, they've said themselves that they want to do hydrogen fuel cell by 2050. So there's these overlaps, or unless it's all the circular information that gets passed around. Right. So that's the first part of your question. The second part with responsible investing, was that right? So how is the financial side of this impacting the industry? And I mean, you raise a great point there with protests obstructing development of energy requirement effectively, right? When we're looking at Shell looking for more oil, this is energy requirements, right? And what we're seeing right now is with the coal story is there's not enough coal in China, there's not enough energy being produced there. There's talking to some analysts, have said there's potentially going to be a humanitarian crisis in the Northern Hemisphere this year because there's not enough thermal coal, there's not enough energy available to meet demand. That means prices are going to skyrocket. The coal price has gone through the roof. I haven't looked at it more recently, but it's at unsustainable levels, which means that what the individual person in Europe and Northern Hemisphere is going to be paying for electricity is going to go up significantly. There's shortage of gas supply from Russia because their supply hasn't been restocked. And then not to mention the lack of truck drivers in the UK, which was part of that other narrative of not being able to bring fuel to where it needs to be. So so moving away from the carbon economy, if you will, is not something that can be done overnight. And this is a problem with sentiment investments, where we're seeing things pulled out too quickly. And this is where we're going to end up in this winter in the Northern Hemisphere now, is going to feel the impacts of that. Hopefully not, and then hopefully we will carry on as is, but this is a very, very strong potential that it's going to have serious impacts. But the money is at the moment not in oil. So companies need to show their direction towards carbon neutrality, their investment in green energy, et cetera, et cetera. Even companies such as Shell and BP, they are doing that. They are investing it. But the demand for oil is still there, right? It's still growing. So yeah, I think it becomes a very social argument, not just political. Political comes out of that. I think it is a very difficult topic, and one that we will navigate either or, but I think we will see some repercussions of stopping one or the other.
Yeah, Nelson, I mean, just to go a step further, I mean, it's the same in this country. How do you tell millions of people that actually you can't use, coal and wood in your fire to cook your meal in the evening or heat your house in midwinter? It's exactly what you're saying. So it's a hugely emotional issue. I mean, you see Barbara Creasy running around and our government saying, well, we're going to get all this 130 billion or whatever it is to, supplement carbon fuels. Well, actually, I mean, it's pie in the sky. And unless it's properly managed, and unless, as you say, it's a long-term program, I mean, it just creates chaos at the end of the day. Mm. Yeah. So, and then just moving on, Michael Conrad, are you there? You've got an interesting point, and I guess it's a case of horses for courses, and it's what Richard's talking about. So we have all this vanadium. Why isn't South Africa? Aren't we, making better use of that for batteries, or building electrical supply that can take the place of some of the lacking Eskom supply? So, Michael, are you there? Maybe you want to comment.
Yeah, I am. Hi, bro.
Michael.
It was really just that I think countries are going to have to start making use of what they've got to regionalize supply chains. And the last thing anyone wants is to see sort of battery cells shipped across the world for an EV that's supposed to be reducing your carbon footprint. And the same with hydrogen, fuel cells, storage. I think there's not a one size fits all for any economy. It's going to be a real mix over the next couple of years, I think.
Yeah, good point. You got comment, Nils?
No, I think talking about the region or the geography of supply chains is important. We're shipping lots of chromite across to China to produce, or lower grade manganese to produce different steels. It's the amount of material being moved around is significant, and all the ships are out of sync at the moment, and the ship prices, the shipping costs are also astronomical on a relative scale to the last few years. But interesting what we're seeing again, and I think personally, I think the whole narrative of moving away from China is the wrong one. And I think we see a lot of opportunities where China is looking across its borders to invest. Obviously, there's history of corruption and staking ownership in properties in Africa through China that one has to be aware of and be careful of. But China is currently the only country that's really shown an interest to invest, be that self-serving. But I think there are a lot of opportunities there to find partners in China and develop the supply chains, not just for China. Ultimately, there's also businessmen there looking to capitalize on these growing markets.
Yeah. Nils, can you see the chat column?
Yeah.
Gene Simonis has got a question there, which again is a relevant one, about all the environmental issues of this great deal more mining that we need.
Yeah. So, I mean, we just had COP26 and zero carbon emissions by 2050. I mean, that's a bit of an average, right? Each country's got its own sort of targets. And I think if we reach that by 2050, well done. I don't think we're doing anyway the right steps to move in that direction. Demand is still increasing, and I think this is a huge topic. But yeah, so the increase, well, this is the whole point. In order to reach this carbon neutrality, we are changing the raw material demand markets, right? It's no longer about iron and steel. It's about lithium. It's about nickel, which is relatively a tiny market. Manganese, which is a big market, and the batteries industry accounts for 2% of the manganese industry, but that is where all the investment and interest is right now. And so for manganese, this increase sixfold is not a problem, but for lithium and nickel, it presents a huge problem. For graphite is in there, and then there's all sorts of new technologies. Niobium, the CBMM in Brazil has invested money in putting niobium into lithium-ion batteries and creating their own markets. Again, so there's the environmental footprints of that. Yes, you're going to see a growth in infrastructure deployment and all of that, and that's carbon footprint is part of this narrative. But we really have to look at the long-term picture of what is the end-use product, what does the end product look like, and does it contribute? And you've had arguments on both sides of the coin, and that used to be the sort of stopper is that, yes, okay, we need to increase, but that means we need to mine more material. It's still less mining than we do for iron ore, right? And so the scale of this is increasing, but these are small markets that they're starting off from. So yes, they have to increase. It will have a footprint, and it needs to be part of that sustainability calculation. What is the actual carbon footprint of doing this, of building an electric vehicle? But at the same time, if the alternative argument is, okay, well, let's leave everything as is. So continue to burn oil, continue to drive internal combustion engines. And we've seen the emission graphs, right? We've seen the impacts of that. Okay, there's, again, I mentioned earlier, believers and non-believers. But, we can calculate that impact. And if you just roll that forward, okay, well, then you draw a straight line. That straight line, unfortunately, doesn't meet what we're calling a sustainable Earth environment. So again, it's a fascinating topic. It's horrifying in some instances, depending what you happen to be drinking at the time. And I think there's many narratives in here, and we need to find a collaborative way to do that regionally as well.
And if I can just add there again, and I'm plugging my hobby horse, Nils, and I really think we geologists probably understand these metals and minerals and their distribution better than most. And you showed that the degree of modeling done these days to use as an exploration tool. And if I look at this country again, we really need to start educating people, kids, and our politicians. It's the same as the climate change debate. Here in Hermanus and the Overberg, we have amazing climate change features. But when you say to locals, well, you actually live on an old beach, that's 25 meters, and it happened a few million years ago, people are almost horrified. No one really understands these topics, and I think we as geologists really need to do a lot more to market and sell our profession and make people realize how important basic geology and minerals are. It's the same as where does the brick and mortar come from, and what are the consequences of using cement? As everyone knows, cement is highly pollutive. Anyway,
Absolutely.
it's been a fun discussion, and I'm sure something we can do again plenty times. So
there's another hand up there from Oleg.
Oleg.
Yeah, thanks, Nils. Great presentation and great overview. I just wanted to ask you, what is your take on the fact that the move to EVs, at least in the vehicle sector, is almost a fait accompli, for example, sake in Europe? Because as far as I'm aware, bulk of the European countries are planning to stop the production of the ICE vehicles by 2030. That's 8 years away.
Yeah.
Are we running a betting program on that, Oleg?
No. Just The only bets that we take are beers as geologists and geophysicists.
No, look.
Where are you based, Oleg? Sorry, Nils.
Go for it.
Johannesburg.
Okay, so we can run a betting program. Henny, are you ready?
Really?
Okay, sorry.
Yeah. I mean, I quickly typed fait accompli into Google just to make sure my French was still okay. But I mean, it's a great point. I mean, what I was talking about in the presentation was it's not cheaper to do this, right? So you have to incentivize your demand markets, and this has been done for electric vehicles. It's been quite spectacular how quickly it's happened. You know, in 2017, if we would have had this discussion, and when I started looking at this industry from a raw material supply chain perspective, people wouldn't, you know, these were the high-end forecasts to some extent, you know, and they're starting to take shape. And it's been done through subsidies and encouragements. And now they're saying, listen, to the automotive industry, they're saying, okay, by 2026, I think it was, they have to have a certain average carbon emissions, and anything above that there's a fee associated with that. And then they calculated that on an annual basis, there were billions of euros that VW, for example, would have had to pay to governments for their existing fleets. And this wasn't just their fleet in Germany, this would have their global fleet, so of vehicle sales that they're bringing to the market. So there was a cost related to not starting this process. And then there's also what's happened. The consumer is now looking to understand, it's like, oh, well, I'd like to own a Tesla, but I can't afford one. And what other options are there? You know, what's this, or what is my car maker doing to be part of the supply chain? I mean, I can't afford a Tesla, but I'd really like to do my part. And so all of these companies are effectively showing promises of what they're going to do, but they're incentivized by actual costs that have been put into law. And so yeah, I think it is that we're at this fait accompli, because we have started this. We have said there's going to be a cost for carbon emissions. So we need to instill that change. If it's the right thing, if we've done the right thing, you know, we will see. But you know, we need the raw materials to meet that demand, and it's a quick ramp up. And you know, we know as geologists how fast and or slow it is to bring a mine to market, and to do that ethically and sustainably. You know, it needs to be done correctly. So yeah, it's a great topic.
I just find it fascinating because if you just look at the ballpark figures, right, there's about 100 million vehicles that are produced and sold globally. These vehicles are produced and sold globally to replace the existing fleet, as well as, you know, the population growth. Most people would like to have the house, the car, the washing machine, etc. So it's going to be really interesting because, like, once we start getting to these figures with electric vehicles, then you're going to see a definite scramble for, you know, all the building blocks that go into these EVs, starting from rare earths to nickel to copper, etc. So it's going to be, we live in the interesting times. I think it was an old Chinese proverb or curse. I'm not sure which one, but we're definitely living in the interesting times.
No, absolutely.
And you got to give it to the boy from Pretoria with his electric cars. I mean, you know, man, he's done an amazing job of marketing, if you want to call it that.
I just find it fascinating that Tesla right now, as we speak, Tesla's market cap is $1 trillion. That's 6 times larger than VW.
Yeah, their fleet is tiny in comparison, right?
Yep.
Yeah, no, it's yeah, they're riding several waves at the moment. But you can also see what's interesting in the whole process, bringing this back to the materials, is the rate at which battery technologies are evolving at the moment. You know, first off in 2017, how do we get rid of as much cobalt as we can, because we're associated with the DRC and consumers won't like that. Policy investors won't put money into that. And now you've got your lithium, nickel, manganese. Manganese is definitely benefiting from this, but first it was nickel, but now there's not enough nickel. So now it's going to continue to evolve, and at some point, we'll never be in a situation where demand exceeds supply. It might just be that some people won't be able to buy what they want.
Yeah.
We'll go back to horse and cart.
Yeah, exactly.
Yeah.
It's very sustainable.
Yeah. Okay, fantastic. Thanks, Oleg, for raising that. And Henny's going to run the betting board, so we could have some fun and raise some money. All right, any last questions? Questions, comments? And Richard, will you follow up or make the first pass with Fortune and Anthony? And I'll follow up.
Yeah, I'll certainly do that. Yeah.
Yeah, it'd be good to have Fortune on here.
Okay, thanks everyone. It was another really interesting presentation and a particularly fun and interesting and very relevant discussion. So we look forward to